Hello, I am Riganku Haldar and now I am pursuing my MSc from Benares Hindu University in Statistics and Computing, and I will pursuing a internship program from the Cosoft, and this is my task 4, that is self prediction problem. And I uh, download a dataset from the Kaggle website, and I completed my tasks from the VS Code using Python programming language. And then, okay, at first I import the necessary libraries as NumPy, Pandas, Matplotlib, Typlot, and Cboard, and I import the dataset and this code pd.read underscore csv, and this is the csv file, comma separated value, okay, and this is the my dataset, and dataset contains the TV, radio, newspaper, and sales. So there are three advertisement platform. There's TV, radio, and newspaper, and this is the sales of some product. Okay. At first, we described some data set, that is the advertisement dot shape. This is the 200 rows and 4 columns. Okay, and this info, that TV with float variable, radio also float, newspaper also float, and sales also float. Okay, and data dot column, that columns, 4 columns contains the 4 columns: TV, radio, newspaper, and sales. Okay, and we check the null values of these data sets. There is this code, dot is null, open parenthesis and close parenthesis dot sum, and this is 0. Okay, there is no null values of this data set. This is the free from the null values. Okay, and we and we check some the statistical value as this code, using this code advertisement describe, and this is, that's mean TV mean 147.02, and the minimum values of the TV advertisement 0.7, and the maximum value of the 296.4.0. Also radio, here radio is 0, radio is minimum 0, maximum 449.6, and newspaper has minimum 0.3 and maximum is 114.0. Okay, and sales, maximum sales is 27 and minimum sales is 1.6. Okay, the highest values advertisement of this TV, and this and sales. Okay, and this is the mean, standard deviation, and okay, and we draw the pair plot using this code sns.pair plot advertisement. This is the data set, and x values is TV, radio, and newspaper, and y varies the sales. So we draw the pair plot with pair plot of sales with respect to TV, radio, and newspaper, and we see there is a linear relationships, exact linear relationships between sales and TV, but radio and newspaper there are no exact relationships. Okay, kind of linear relationships. Okay, exact, not exact linear relationship, but exact linear relationship. Okay, and we draw the box plot respect to advertisement, TV advertisement, newspaper advertisement, and the radio advertisement and newspaper advertisement, and using this column, within this code, this is the figure.ax subplots. We create the 3 subplot with fixed size 10 by 10, and this code. Okay, and uh, color of the box plot is with respect to TV is red, and green also newspaper, and blue also radio. Okay, and easy, and this box plot is TV. There is no outlier. This is a kind of symmetric distribution. Newspaper, this is 2 outlier, and this is a kind of uh, positively skewed distribution, and this is a kind of symmetric distribution. Okay, and we draw the hist plot uh, using the previous code as well as previous code, and this is the box plot. Okay, so the newspaper has a positively skewed distribution. This is no exact any specific distribution, but this is a positive skewed distribution of newspaper. Okay, this. and we draw the heat map, the correlation heat map, using this code. This is the positively correlation between the radio or TV or newspaper, also radio 0.35 with the highest correlation between the 0.55. Okay, so now we fitted a appropriate model of the using the dataset, and this is the mm, at first we import the some libraries for fitted the model. This is the scale and dot model selection, import 10 test split and model linear regression, and scale and dot matrix is the mean square error. Okay, at first we um, at first we x test, this is the our the dependent variable, sorry, independent variable. This is the our we define the dependent variable and independent variable. This is x test is the our the independent variable. This is the TV, radio, and newspaper. And y test, this is the our dependent variable. This is the cells. And import the another library stat models.api as same. So we fitted the uh, ordinary least square by this code. This is the x1 test xm dot at underscore constant. So we add a, constant value in the independent variable, and then and this is the OLS regression method where the R square value is the 0.93 and the adjusted R to the 0.9. This is the this is the same, and 0.93 this R square value is very high. The 0.9 is the model is the best fitted. Okay, and the constant with coefficient 4.6 with probability 0, TV with coefficient 0.544 with probability 0, radio also 0, newspaper the 0.95. So newspaper with coefficient 0.3 and probability value 0.95, this is the insignificant, because the probability greater than t value is always less than is 0.05, then this model, then this is the significant. But if the greater than 0.05, 5% level of significance, that is the insignificant. So newspaper of this model, this is the insignificant dependent variable. Okay, and this is our models. Why this is our regression model, that's the linear regression model. And we calculate the residual by this code. We have model dot resid, this is our residual. And we divide the trend test and this column, and with test type 0.2. So we using for testing, so 20% of the data set, and we fitted the we train the data set with the using the 80% of the data set, and random set 22. Okay, so the train data set length is 160 and test data is 40. Okay, so we fitted this the linear regression, and the predicted value is this. Okay, by this column y underscore fit lr dot predict x test, this is our predicted value, and this is our the observed value. So this is the kind of same. Okay, okay, and we plot the residual. This is a kind of normal distribution with 0. So this is the linear regression is the best fitted model, and this is and okay. Thank you.